The spatial data types are built using an object hierarchy. At the top, there's either geometry or geography. Both of these data types have a very similar set of objects, and so I can kind of talk about both of them at the same time. And then there's a number of objects below them. The point is one of the objects that you're probably going to use fairly frequently. A point is identified by a pair of coordinates, such as an exact location as x and y coordinates, but it also can include a z for elevation and m for measure. SQL Server doesn't use the z and m coordinates, but it lets you store the data so that the client applications can use them for their own calculations. And you can also use a point with latitude and longitude information. Okay, then there's an abstract object. So in this hierarchy, yellow objects are abstract objects that you can't use directly. Instead, they provide the custom functionality for a group of objects, one or more objects. So within a curve, you have a line string. This is another object that you'll probably use quite a bit because it represents a string, a line. It's a path along a sequence of points, and it's important to understand that it's a sequence of points. It's not just 2 points. So this is a one-dimensional shape. It has length but no area, even if multiple connected line strings look like a closed shape. The line string is simple if it doesn't cross itself, or a ring if the starting point is the same as the ending point. And then another common object that you probably use is a circular string, which is also derived from curve. This is similar to a line string, but it defines a curve as a portion of a circle instead of as a straight line. And this is an enhancement to SQL Server 2012. And it makes it much easier to work with shapes that have curved borders. All right, then another shape is compound curve. This is a way of combining line strings and circular strings into more complex shapes. And then there's another abstract object called a surface. And one of the objects here is a polygon, which is another object you'll probably use quite a bit. This is a closed two-dimensional shape, a ring. A polygon has both a length property and an area. It can have holes in its interior, the shapes of which are defined by other smaller polygons. And then the area of a hole is excluded from the area of the outer polygon. And I'll show you some examples of that. Okay, then there's also a curved polygon, so you can create polygons with curves essentially. And then the one difference on this chart between the geometry and geography type is the full globe. So that's why I have that in a little fainter color with the dashed line, because it only applies to the geography data type. And so this represents the entire surface of the Earth. In SQL Server 2008, which first introduced the spatial types, a shape on the surface of the Earth couldn't be larger than half the globe. And in 2012, Microsoft eased that limitation and added this additional shape that you can use in order to work with the entire surface of the Earth. So for example, if you want to calculate the area of the surface of the Earth, you can just use the stArea method in order to calculate the area of the Earth. And I'll talk more about the properties and methods a little bit later. All right, then if you want to work with collections of shapes, you can use the geometry collection or geom collection object. So one of the items here is multipoint. And multipoint is just a collection of points. That's the only kind of shape, only kind of spatial data type object that you can have is a series of points. And so it makes it easier to work with those points as a single object. And then there's another abstract class called multicurve, which has a single object, multi-line string. And so like multipoint, multi-line string is an object that allows you to have a collection of line strings. And you can only use it with line strings, no circular strings, no polygons, or anything else. And then there's also a multi-surface, which has a multi-polygon object. And so you can have multi-polygons. So again, the multipoint, multi-line string, and multi-polygon can only hold objects of those types, point, line string, or polygon. If you need to mix shapes, then you'd use the geometry collection. Okay, so the way this hierarchy of object works is that you define a field or variable as either the geometry or geography data type, then assign to that field or variable data that describes the point, line, shape, or collection that you want to store within that variable or column in a table. Okay. Again, the yellow objects are abstract objects, so you can't directly instantiate those kinds of objects. But you can directly instantiate the blue or the darker objects, because those are concrete objects and you can store these in the spatial data type. And again, the only difference between geometry and geography is the full globe in terms of the objects. There are different properties and methods, but for the most part, geometry and geography also share a substantial number of properties and methods. The shapes defined by the various spatial objects are vector objects, which are collections of points, lines, curves, polygons, and compound curves. And as I was describing the hierarchy, I pointed out some of the ones that you'll probably use most commonly. But it really depends on what kind of applications and what kind of shapes that you need to use within your database and client applications. The geography and geometry data types are .NET classes implemented as system SQL CLR objects with several dozens of methods. Many of the methods, roughly about 2/3, have names that start with the prefix st. For example, things like stArea, stLength, stDistance, and stGeom from text. These st methods are implementations of the Open Geophysical Consortium's standard methods. And, by the way, the st stands for spatio-temporal. So these methods provide the most commonly used basic features for working with spatial data. And then, Microsoft being Microsoft, they also added some custom extension methods to all of the objects in order to support features that aren't part of the OGC standards. And these methods don't have the st prefix, and they include things like parse, toString, and reduce. The nice thing about the geography and geometry data types is that they share a lot of methods that work the same across the two types. The main difference is that with the geography type, you'll use latitude and longitude coordinates, but with the geometry type, you'll generally use x and y coordinates. But what you really use with geometry is up to you, the measurements. In the world of spatial data and map making, there are a whole bunch of different ways to represent spatial data. And SQL Server supports 3 data formats for the shapes that it supports, all of which are standards of the Open Geospatial Consortium. One is well-known text, or WKT. Another is well-known binary, WKB. And the other is Geography Markup Language, or GML. As you can imagine, well-known text is text-based, and I'll be mostly using that within this course. And then well-known binary is a more compact, efficient format, but it's in binary, so it's a little bit harder to work with directly. And then the Geography Markup Language is just XML. But the nice thing about this is that even though within your code you're most likely to use well-known text, again because it's just much easier to use, but with the support for these 3 different formats, you can import and export data from a variety of sources and convert it as necessary for your applications and store it within SQL Server. Now here are a few sample well-known text representations. Here's how you can define a single point in a grid system at coordinates 2, 5. An important thing here to notice is that the coordinates, the x and y coordinates, are separated by a space. And then for shapes that require using multiple points to define them, such as a line string, because you need a beginning point and an ending point, then you would have a 2 space 5, and then a comma, and then another point. 2 points separated by a space. All right, then another example is line string, 25, 50, and this shows that comma delimited separation of 2 different points. So this represents a straight line from the point 2, 5, 2 on the x-axis, going up 5 on the y-axis, to the point 5 on the x-axis, and 0 on the y-axis. And then this third one defines a polygon that starts at 0, 0, traces through several other points in the clockwise direction, and then returns to 0, 0 as its final point. Okay, so can you picture what the shape looks like? So you start at 0, 0, you stay at 0, you go up 4, so it's a vertical line up, and then 6, 4, you're staying on the same place in the y-axis, so it's a horizontal line, and then 6, 0, it's using the same 6, so it comes down, and then 3, 2 kind of does some sort of jog or something, and then it goes back down to 0, 0. Okay, well, here shows all three of those shapes. And to this image, I've added some text annotations that identify the points a little bit more clearly. Because unfortunately, there's no way that I know of anyway to change how Management Studio displays that light grid background. So again, this is a screen capture of something I did within SQL Server. And the other thing I did is I emphasized the size of a point. A point doesn't have area, so it really wouldn't show up here very well. And so I just used a feature of the spatial data types in order to put a buffer around it. So that point at 2.5 really doesn't have any area, but I just wanted to show you where it's located. Okay, another thing about this is that I want to caution you, don't be confused by the labeling of the numbers on the x-axis in that figure. So you can see that the numbers are about 3/4 of the way up the top, even though the 0, 0 coordinate is way down in the lower left. Again, this is an image capture of the shapes that I displayed from a query that I executed in Management Studio. And Management Studio provides the axis numbers so that they're visible, but not always on the actual axis. The x-axis is in fact at the bottom of the figure, as you'd expect. Just the number labels have been displaced. So don't let that confuse you about where things are located as you look at these shapes within Management Studio. Another thing I want to point out is that the well-known text for the polygon that I'm showing you here includes 2 sets of parentheses around the text shape definition. This is not a typo. The reason I had to do that is because you can define inner rings as part of a polygon to exclude internal areas, and I talked a little bit about that. And so the first comma delimited set of points, and delimited with an inner set of parentheses there, defines the outer shape, or the ring. And then I can add a comma after that first set of parentheses, and then another set of parenthetically delimited points in order to define inner rings that are excluded from the inside of the polygon. So a little bit funky notation, but when I just want to define a polygon like this without excluding anything on the inside, I need to use 2 sets of parentheses like that. Here's some code that creates a variable of type geometry and sets its value to the value of this well-known text right here. So in this case, it's going to create a line string object. In order to create the object, it uses the stgeom_from_text method. And here you can tell that the code is calling a static method of this geometry object because it's using this double colon operator. For instance methods, once I have an object in memory of a particular type, then you'd use the dot method to call a method or a property. Okay, so this is the well-known text. It's drawing a string from the point 515, 2210. And then the second parameter here, which is 0, is the spatial reference ID, or SRID, SRID. For SQL Server to use multiple objects for calculations, all of the objects have to be part of the same spatial reference ID. When you're not working with a particular type of projected data, if all the objects are the same type in units, or if you're just working with a single object, the convention is to use 0, as I did here. Using 0 doesn't identify the shape with any known spatial reference ID. Okay, so once this line executes, then I do a select line, and that just displays the value of that object. I'll go ahead and execute that. And there you can see the binary representation of a line string object that we defined. And the format of the binary data is documented, and so if you want to go in and extract different parts of that, you can write applications that do that. Go crazy. What's new here, though, is that because I executed a query that returned a spatial data type, I also got the Spatial Results tab here. And as you can see, this provides a view of the shape on a two-dimensional plane. So this provides a simple way to visualize shapes. Now, if the results set returned multiple spatial data fields, then I could select them from this column here. I didn't use an alias, so it's just called no column name. But if I had select line, select polygon, select other values here, then I could select which one I want to display here within the viewer using this drop-down list. And then if you have another field that provides labels for points or other kinds of shapes, then you can select which label identifies the objects with that drop-down list. And then you can also do things like zoom this figure, and you can opt not to show grid lines. So as you can see, the Spatial Results tab has fairly limited functionality, but it can be handy to visualize results as you work with spatial data. But for the most part, when you really need to visualize spatial data, you're going to want to use either some kind of client application that you create, or there's lots of third-party applications and tools that go far beyond what's available in Management Studio. So this is a nice convenience within Management Studio, but it only goes so far. But the nice thing is it's sufficient for our purposes here. All right, so this method that I used here, stgeom from text, takes well-known text, that's what the text part of the name is, and determines what kind of shape to create from the text that I pass to it. So this can create any kind of shape. I happen to pass a line string object here, and so it created a line string. But the spatial data types also have object-specific methods, and that's what I did right here. So here I'm using stLine from text. So not a generic object, but I specifically want to define a line string. And so otherwise, this code is identical. If I execute this, get the same result there, and I get the same line. Now, these methods are smart enough so that if I pass it the wrong kind of object, then it won't let me get away with that. And it'll throw an error. So here what I'm doing is I'm using stLine from text, but instead of passing it a line string, I'm passing it the definition of a point, well-known text for a point. And it'll create a point at 10, 100 coordinates. Okay, when I try to execute this, you can see I get this exception. And again, it's because I'm passing the definition of a point to a method that expects a definition of a line string. And this is probably the first tangible evidence that the data types are implemented as .NET Framework types, because this is a .NET Framework type of exception. And so the message is a .NET Framework error occurred during execution of user-defined routine or aggregate geometry, blah, 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 expected line string at position 1. The input has point 10 and it truncates the rest of the statement. And then you can see the call stack for this particular method. And the interesting thing is that when this kind of error is raised, what the results return is a null. And if you look at the Spatial Results tab, you just get this empty grid. There's nothing defined there because it can't do anything with null values. Both the geometry and geography data types have a rich set of methods for creating various objects by using all of the data representation formats that SQL Server supports: well-known text, well-known binary, and geography markup language. Both data types use well-known text by default. So you don't even need to explicitly use the geometry type to create something. So all three of these statements result in the creation of the same object in the line variable. So this one uses geometry from text. This uses the extension method. Notice that this doesn't have an ST prefix, and so this is a feature that Microsoft added to the geometry data type and the geography data type so that you can parse different data formats that you pass to it. But even that's not required. If you define an object as geometry or geography and then set the value to this, then what happens is that SQL Server implicitly calls the parse method to figure out what kind of data format you're sending it and what's being defined, and then does the right thing with that line object and creates the right variable. Now, if you have an existing object and you want to retrieve the well-known text data representation, you can do that with the toString method. This is another bit of evidence that these objects are created using the .NET Framework because all objects in .NET have a toString method. And so this is just the standard .NET method that's been overridden in the geography and geometry data types in order to return some sort of string-based representation of that object. So I once again create a geometry object do stgeom from text, pass the line string, and then do toString, and execute that. And there you can see the binary format, and then there's the well-known text format. Now it's important to understand that when you use toString, I have to call that against an instance of either the geometry or geography method. And because this is an instance method, I have to use the dot notation instead of the double colon notation. Again, this is for a static method, or shared if you're used to Visual Basic. But this is an instance method, so I have to call this on an existing geometry or geography object. Okay, then, as is typical for SQL Server, and as it turned out for geospatial standards, the types have a whole bunch of methods that you can use to get information about a shape. For the most part, you won't need to write any custom code to do things like calculate areas or perimeters. And so this code here creates line, string, point, and polygon objects in 3 variables. And then it executes a select statement in order to return the binary values there, as line, as point, as poly. So this time I gave them the aliases. And then the second select statement calculates the length of each of those shapes. And then finally, this third select statement calculates all of the areas of those shapes. So if I execute all this code as a batch, there are the binary representations. Then there's the calculation of the lengths. So again, the first object is a line, and that has a length, and it's 17.72, whatever the measurement is. And then a point has no length, so it properly returns 0. And then the polygon length is 21.21. And so this is the length of the perimeter of that polygon shape. And then here are the area calculations. A line has no area, so it returns 0. A point has no area, but the polygon has an area of 18.